Now, in this video, we will going to take up one more problem on the projections of lines, the problem number 53. The top view of a line capital AB, 80 mm long, measures 65 mm, and the length of the front view is 50 mm. The NDA is in HP and 15 mm in front of VP. Draw its projections. So the problem is given like this. So first we are going to analyze this problem in 3D. So here what he says is he has given the true length and he has given the front view and top view, and one end point is given, NDA is in HP and 15 mm in front of VP. Since the NDA is in HP, so when you look from the front view, we can see that the point lies on the horizontal on the vertical plane A dash. Then when you in front of VP by 15 mm, so when you look from the top view, the NDA is in front of VP by 15 mm. So this is the distance. When you look from the top view, the image falls on HP. So you're going to mark this point as small a. Then as he is given the length of the front view and the top view, we know that if the front view line is parallel, correspondingly its top view is in true length. If the top view line is parallel, then correspondingly the front view line will be in true length. So that is the condition. So here, first we're going to take up the top view line, which is 65 mm, which should be parallel to VP. Then only we will going to get the true length in VP. So NDA is in VP. NDA is 15 mm in front of VP. So the B1 should also be in front of VP by 15 mm. So the length of this top view will going to be 65. You can see here, when it has been rotated, you will going to get this length is 65. So once you take this line as 65 and when it is projected here, so you will going to get this length will going to be 80 mm. So this is the true length. So we have the true length, that is capital A, B1. So how we are going to consider that? So when you make this parallel in the top view, so when you make this parallel top view, its true length will going to be, it is in space. Here you can see that you have this length will be equal to 80 mm. So when it is projected, that projection we can see A dash, B1 dash, which is the one which will going to be in the front view. So here this AB1 is the one which will going to be parallel to VP. So when it is projected, you will going to get this length. So here you take this to the front view and take 80 mm and cut an arc on this, so that you will going to get this length, which is 80 mm. So now we got the locus of B in the front view. So similarly, so that means what you are trying to do, similarly what we can do is, now we are going to take up the top view now. Now when the front view is 50 mm. So first what we will do, we will going to take NDA, A dash is in HP, so B2 dash should also be on HP. So that means you have 50 mm, make that parallel to HP. Once you make that parallel to HP, so you are getting the true length in HP. So from here you draw a projector here, and then with A center taking the radius of 80, cut an arc on this, so that you will going to get A, B2. So you'll go to get the locus of B in the top view also. So once you get this, now we need to get the front view and top view now. So where is the top view? The top view is AB1. AB1 is in front of EP by 15 mm, but actually B is in front of EP by this distance. So we know that length of the top view is 65. With A center taking the radius of AB1, you rotate it and make it so that you will going to get touches the locus of B in the top view. So you will going to get AB, draw a line with a dark line. Then similarly, since you have the locus of B in the front view, so A dash, B2 dash is on HP. So B2 with A dash as center taking the radius of A dash, B2 dash, you rotate it, and so that it will going to get the locus of B in the front view, and you mark this point as B dash and then join A dash, B dash. So when these two are projected, you will going to see that you will going to get the point which is in space. So what actually it does is, now this is the other way of doing it. Now we will going to explain this when in the another direction. So when I rotate with A as center taking the radius of AB, you rotate it and make it parallel to HP. Once you make it parallel to HP, so you are so here you are rotating like this. So once you make it parallel to HP, so you are getting the true length in HP. So you got the true length in HP. So what happens to the image? The image in vertical plane is rotated from B dash. So you're going to get A dash, B2 dash. So when it is projected, you will going to get the true length in the top view. Similarly, when you rotate like this with A as center, taking the radius of AB, so that both A and B1 will going to be in front of EP by 15 mm, then only the line will be parallel. So once you get that, so you will going to get the true length here. So this is how you will be able to get the A dash B1 dash, which is going to be the locus of B, which is in the front view. So this is how we can able to analyze this problem. So it is just exactly the reverse of this, because since we have not given the inclinations, so we are supposed to find the inclinations. But he has given the front view, top view and true length. So the condition for the line to be in true length is if the top view line is parallel, correspondingly the front view will be in true length. If the front view line is parallel, correspondingly the top view line is in true length. So this is the concept, this is the condition which has been used to solve this particular problem. So this is how in step also we can say that if I want to find the true length in the front view, so we have to take the top view. So what we have done, but top view inclination is not given. So since the top view inclination is not given, we cannot take this directly. So first we have to make this line parallel, so that A is in front of EP by 15 mm and B1 is also in front of EP by 15 mm. Then you make this line parallel to VP. Once you make this parallel to VP, then you will going to get the true length in the vertical plane. So you are projecting this line to the vertical plane. Then with A dash as center, take the radius of AT, cut an arc on this. So you're going to get the locus of B in the front view. So that means if this line is 65, then this line will going to be 80 mm. So that is the meaning of this. So that is how we will be able to get this. Now when it is being rotated, so once you get this, so we are not able to get this because we have not found out the locus of B in the top view. So we have found out only the locus of B in the front view. So how we have done? So we have taken the initially that top view distance of 65, you make it parallel and you project this, then take 80 mm and cut an arc on this. So you're going to get the locus of B in the front view. Now we need to find out the locus of B in the top view. So how to find out the locus of B in the top view? So here you take the front view line parallel. So what is the length of the front view? The length of the front view is 50. So we make it parallel here. So A dash, B2 dash, both are on HP. So that means it is parallel to HP. So therefore you are getting the true length in HP. So this is the HP. So with A dash, when you are projecting this with A as center, taking the radius of AT, cut an arc on this. So you're going to get B2. Then you're going to get the locus of B in the top view. So this is how you will going to get this. So that means when you make it parallel here, you get this. So then you project this to the top view. And then you know the true length of the line, which is 80 mm. With A as center, take the radius of 80, cut an arc on this. So there you will going to get the locus of B in the top view. Once you get the locuses, then what you can do is you come down to this. So once you find out that, so with A dash as center, taking the radius of A dash, B2 dash, you draw an arc so that it will going to cut the locus of B here. So that you will going to get B dash, which is different view. And similarly, with A as center, taking the radius of AB1, you draw an arc so that it will going to cut the locus of B in the top view. So that you will going to get small b, then join A to B with a dark line. So this is how you will be able to analyze this problem in both 2D and also on 3D. Now we will going to try to solve the problem by using the sketchbook. So how to do that? First we will going to draw the XY line and mark VP and HP as shown. So then he says NDA is in HP. So obviously A should be on XY line in the front view and 15 mm in front of VP. In front of VP is seen in HP. So obviously from A dash you draw a vertical projector, measure a distance of 15 mm and you mark this point as small a and then draw a horizontal line. Now we know that the condition is if the top view line is parallel, then correspondingly its front view is in true length. So what is the top view line? The top view line is 65 mm. So from A you measure 65 mm and mark this point as B1 so that AB1 is parallel to XY line in the front view. That means A is in front of VP by 15 mm and B1 is also in front of VP by 15 mm. Then only the top view line is parallel. So AB1 is parallel to XY in the top view. Its corresponding front view will going to be in the true length. So A dash is on XY line. So from B1 you draw a vertical projector to the top side, that is to the vertical plane. With A dash as center, by using the compass, take a radius of 80 and cut an arc on this so that you will going to get this point as B1 dash. and then draw a dashed out line and mark this as locus of B. And this is capital A. As we know that this line is parallel to XY line in the top view, obviously this A dash B1 dash will be in true length. So what is the true length? The line capital AB. So you have written capital A and you write capital B. Similarly, now we will going to take the front view. So we need to find out the locus of B in the top view. So to do that, to take the front view line. So what is the length of the front view? The length of the front view is 50 mm. So A dash is on HP. So obviously the other end of B in the front view should also be on HP. So what is that other end of the front view point, which is A dash B2 dash? You can take that this distance is 50. So from A dash you measure 50 mm and you mark that point as B2 dash on XY line, and then draw a vertical projector to the top view. Now the line is parallel to XY line in the front view. Its corresponding top view will be in true length. What is the corresponding top view of A dash B2 dash? It is AB2. A we have, we don't have B2. So to find out B2, you take the radius of AT by using the compass with A as center. Cut an arc on this. Cut an arc on this vertical projector so that you will going to get the point as B2, and draw the locus dash dot line here in the top view and mark this as locus of B. And also, as we know that this is the front view is parallel to XY, so its corresponding top view will be in true length. So AB2 will be in true length and joint between A and B2 with little bit thicker than the XY line, and you mark this as capital A and capital B. So once you get the locuses, then it is very easy to find the front view and top view. So we know that the front view line is A dash B2 dash. So A dash and B2 dash is both on XY line. So but B2 dash should above HP by this distance. So with A dash as center, taking the radius of A dash B2 dash, you would draw an arc such that it will go to cut the locus of B here, and you mark this point as B dash and join A dash B dash with a dark line. And similarly, AB1 is in front of EP by 15 mm, but actually B is in front of EP by this distance. With A as center, taking the radius of AB1 by using the compass, you draw an arc such that it will go to cut the locus of B here, and you mark this point as small b. Then join A to B with a dark line. Then join B and B dash, both will going to lie on the same line. So then you show the dimensions and you mark this theta, that is the true inclination with respect to HP, and alpha apparent inclination with respect to HP, and phi true inclination with respect to VP, and beta it is the true inclination apparent inclination with respect to VP. So this is how you will be able to analyze and solve the problem using the sketchbook on the projections of lines. Thank you.